current through both the resistors are same. Just calculate
Ma'am, R2 is 290 and R1 is 145.
see here no need to calculate resistor value. You just calculate the output. Okay. See, what is output? Output is gain is already given, it is 15, and the input is also given, it is 0.25. So output is gain into input, so it will be 3.75, I think. That is the output value. See, determine the output voltage first. So that is to be done, and after that you have to find the currents in the resistor, not the resistor value but the current. Resistor value you have already calculated. It is R1 is 4.17 kilo ohm and R2 is 58.33 kilo ohm. Just calculate the current through both the resistor values will be same here. So current will be input, you can calculate in any way. One way is current will be given by input divided by R1. Okay, so what is R1? It is 4.175, and input is given, it is 0.25. From that you can calculate the current.
Yes, ma'am.
If you want me to
VO is
repeat, yeah,
3.75.
yeah. How much? We output is yeah, 3.75 volt. And what is the current? See, for calculating the current, you just divide input with R1. Input is given, it is 0.25 divided by R1, it is 4.17 kilo ohm. You'll get the value of current. Current through both the resistors are same. You can calculate for any of the resistor value. That is fine.
Ma'am, I2 is 0.06.
It is 60 microampere. See, 0.25 divided by
Yes, ma'am. Yes,
4.17.
ma'am.
It will give, yeah, it is 60 microampere.
Yes, ma'am.
Yeah.
It's yeah.
Okay. Yeah. Uh, okay. Mm, Next question we can do this one, 9.43. For the circuit in figure is this one. Okay, the input voltage is given, the output voltage is given. Determine the finite open loop differential gain of the op amp. Okay, yeah, calculate that. See, first what you have to do is calculate the voltage at this point. This is the input. Okay, so what is output? Output is this differential gain into this one VB. I mean, whatever be the value, if consider this value, this voltage as V. Okay. So what is output? Output will be this open loop differential gain into this value V. So how to calculate the voltages at this? Apply. hmm, So voltages at this point will be this resistor divided by 1 plus 500 kilo ohm. Voltage division. Apply voltage division here. So what is the voltage at here? It will be 1 divided by 1 plus 500. Okay, into this value input. And what is output? Output, what is output? Output will be AOD. This is that is open to differential gain. Output will be V output will be equal to AOD into this value, this, that is the input. Okay, calculate the input. Input is VI. This is VI. You can calculate this is VI. Input to the op amp. So it will be the voltage at this value. So what is output? Output is AOD into this value. Let it be V. AOD into V. So output is given, input is given. You can calculate AOD from that. If it is not clear, I can repeat. See, first calculate the voltage at this point. Okay. Apply voltage division here. What will be V? If you take this value as V, what will be V? It will be 1 divided by 1 plus 500 into input. Okay. So, and what is this value? V out will be AOD into this value, whatever we got here. Okay. So this value will be in terms of input. Oh, so what is the formula to calculate AOD? AOD will be V output divided by this value. Okay, this is in terms of this, and VI is already given. It is 5, and V naught is also given. Are you able to obtain it? Where you are stuck? See, the answer AOD is 250.5. Are you able to obtain that? Please respond. Am I audible? Hello?
Yes,
Hello? Yeah, yeah. Where you're stuck?
for me it is 1.5.
See, okay. See, the formula is like this. Input, okay. See, out. What is output? Output is nothing but AOD into input. Okay. Or you can say that AOD is nothing but output divided by input. So input at this point you have to calculate by this voltage division. Okay. And then you will easily get AOD. It is 250.5. AOD is nothing but V output divided by V input. Input we have to calculate at this point. So apply voltage division here. It is nothing but input into 1 divided by 1 plus 500. And this is value is given. It is 5 and V output is 2.5. And you will get 250.5. You'll easily get it. Divided by 5, okay, into this voltage division, that is 1 divided by 1 plus 5 500. So just take a reciprocal of that, it will be 500 501 divided by 1. The final AOD will be 2.5 into 501 divided by 5.
Yes, ma'am, can.
Yeah, you got it. Okay. Okay, just calculate the output value also. If the open loop, oh, okay, no need to calculate this one. It is similar. Okay, we'll move on to the next question. Okay, yeah, you can do this one. Determine the output voltage as a function of VI1 and VI2 for the ideal non-inverting op-amp circuit in figure. This is the figure. So determine V output as a function of VI1 and VI2.
VI1 minus VI2.
Hello? Hello? Yeah, tell me.
VI1 minus VI2 I3.
See, no. See, I'll tell you how to calculate. See, this is a non-inverting op-amp, okay? So what is the output of a non-inverting op-amp? It will be the ratio of one. It will be one. It will be output will be gain into input. Okay. What is gain? Gain will be 1 plus RF divided by R1. Okay. Here what is RF? It is 50. This is also 50. Okay. So what is V output? V output is 1.3. Now gain you got, it is 1 plus RF divided by 50 divided by 50. Now it is gain multiplied by input. What it is input? You have to calculate input at this point. Okay. So how will you calculate? Just applied voltage division at here. So input will be at this point it will be the summation of these two. Okay. How will you find this voltage across this one? It will be 20 divided by 20 plus 40 into input. Okay. And the other value will be and this one will be 40 divided by 20 plus 40 into this one. Okay, the final value, so when you multiply this with the gain, the final value will be V out is equal to 1 plus 1.3 1.33 VI1 plus 0.667 VI2. So output is 1.33 VI1 plus 0.667 VI2. They are asking you to see, write the output in terms of the input.
Yes, ma'am, got it.
Yeah, okay. Yeah, I don't know whether we have time. You can do question number 9.4. Next question you can do. Consider the ideal non-inverting op-amp circuit in figure this one. Okay, derive the expression V naught as a function of VI1 and VI2. Um, and yeah, you can do that for the circuit. That you can do it by yourself. Okay, otherwise we'll stop it at here. We don't have time to solve this one. Okay, we'll stop it at 9.44. Okay, let me download the attendance.